So very good evening, all of you guys. Welcome to the channel. Welcome to our Kreatryx question series by the team Kreatryx. Yesterday class we have discussed. Sorry. Yesterday class we have discussed the problems on network analysis. Today we are going to deal with the digital circuits. So let's discuss on the digital circuits. Expected question series on the digital circuits. So let's start the session. So as usual, we have 25 questions in this session from all the chapters. As electrical engineering students are also present in the class, I have not included the questions from what we call logic families and also semiconductor memories because it is not present with the electrical engineering student syllabus. So I kept only common part in this particular session. So this is the current offer running on with Unacademy guys. आपको 23% ऑफ मिलेगा आपका Unacademy का प्लस सब्सक्रिप्शन पे. यूज द कोड Shankar10. You will get 23% off on the subscription. So this is valid up to the January 6th. So today is 3rd. We have 3 more days to avail this offer, guys. If you are aiming for 24-25, definitely you can take the subscription using the code Shankar10. You get 23% off on the subscription. And these are our toppers from 2023-2022 ECE examination from electrical and ECE engineering stream. And these are the present batches running on with Unacademy, that is the Udan batch and the Union batch. Both are for 24 and 25 aspirants. Those are aiming for the GATE and PSU examinations. This is the batch started on December 21st with network analysis. If you want to take the subscription and start your preparation, you can start with the network analysis definitely. So this batch is having many advantages like comprehensive coverage of the syllabus with 5,000 plus practice questions, regular doubt solving sessions, practice through DPP and many advantages. आपको वर्कबुक मिलेगा, doubt solving sessions मिलेगा, test series मिलेगा, and in a comprehensive way you can complete the entire syllabus. So let's start the questions here. Just a moment. Okay. So total 25 questions. We start with the number systems today. I mean, in the first part. So the first question is ready for you guys. So we can start the session with the number systems question. Let's start. So what is the base of the numbers for the following operation is to be correct, that 54 to the base b by 4 base b equal to 13 base b. So what is the base b? That is the question. So now I have already replied to you yesterday. I think after 6th or somewhere RIB log is going to taken by Ankit Goyal sir. Okay, I'll ask him if sir is not taking, I'll take. Okay. Yes, Bhuneshwari, after today's class, in some free time, I will share that. Voice is not clear. Any issue with the voice? Other students, please confirm. My audio is clear or any problem? ऑडियो पे कोई दिक्कत है क्या? ऑप्शन बी और सी बोल रहे हैं आप लोग. ठीक है, टाइम अप. So let me give you the explanation. 54 to the base b can be written as 5b plus 4 by 4 into is equal to b plus 3 because base is b into 1, this one. So this will give me 5b plus 4 equal to 4b plus 4 3 so much 12. So your b is equal to 8. I just multiplied each digit with its positional value. I converted into decimal equivalent and I have done the necessary operation by just taking this 4 and multiplying here. So 5b plus 4 by 4 equal to b plus 3, 5b plus 4 equal to b plus 3 into 4, that will give me 4b plus 12. So if you take this 4b that side and 4 this side, you get b equal to 8. Next question. Sure. Sure. If two numbers in XS3 code are added and the result is less than 9, then to get the equivalent binary number 0011, that is 3 is to be subtracted, 3 is to be added, 6 is to be subtracted, or 6 is to be added. What is the right answer? Please give a try and tell me the answer. So time up. Option. What is the answer? See here. Suppose, for example, uh, 2, 3 plus 4, 5. Okay, 16, 8 is the answer. 2 in the binary is 0, 0, 1, 0. But XS3 में 2 is 5, XS3 में 3 is 6. XS3 पे 4 का मतलब 7, XS3 पे 5 का मतलब 8. Now the result is how much? 0, 1, 1, 1, 1. Okay, 1 plus 1, some 0 carry 1, some 0 carry 1, 1, 1. This is the answer. So here, to get a valid answer, generally what we do is subtract 3. When there is no carry, we generally subtract 3. Okay. If you subtract 3, this result will be 14 minus 3 कितना होता है सर? 11. And 12 minus 3 कितना होता है सर? 9. So this is 6 and this is 8 in XS3. XS3 में this is equal to 68. Okay, fine. But examiner want the result should be in the binary. If we want the result to be in binary, we should subtract one more 3. That is 1001, 1011. इससे भी आप 3 subtract करना चाहिए. Then you get this as 8 and this as 6, 68. BCD. ठीक है? So BCD 68 होता है. So इसलिए generally this is 1 3 and this is 1 3 total. How much to be subtracted? 6 is to be subtracted. That's simple सी बात है भाई. XS3 में for each digit we add 3. So here we have added 3. Here we have added 3. So total 6 will be added in the result when there is no carry. Okay. Total 6 will be added in the result. To get a valid binary answer, you should subtract that 6 from the total result. So what is the answer is 6 is to be subtracted. If you want the answer in the XS3, then 3 is to be subtracted. Okay, chalo. Okay, chalo. Let's go for the next question. Find the product of the two numbers which are given in the 2-bit, 8-bit to 2's complement numbers. So all ones 1010, all zeros 1010. These are the two 8-bit numbers. Their product in the 2's complement representation is. Okay, you need to find its product in the 2's complement representation. So please give a try. Little fast, quick. Okay. So we are in the third question of the 25 questions. Result is less than 9 का मतलब क्या है भाई? There is no carry. That is the meaning when the result is less than 9. Result is less than 9 है ना here. 8 is less than 9 or more than 9. This is the meaning of the result. ऑप्शन सी बोल रहा है कन्वर्ट. ठीक है, कन्वर्ट. लेट मी चेक द आंसर. सो जैसा नंबर्स दिया तो आप लोग ये मत करना पूरा कैलकुलेशन करने के लिए बहुत टाइम लगेगा. मैं आसान मेथड बोल रहा हूँ. ठीक है. सो a इक्वल टू 1 1 1 1 1 0 1 0. ठीक है. सो यहीं पे ऐसा देख लो, ये नंबर, ये वंस जो रिपीट है ना इसको छोड़ दो, इसको बोलते हैं साइन एक्सटेंशन. सो हियर यू अप्लाई 1 2 4, ये जो वंस है ना इसको नेग्लेक्ट करो, कोई कोई बात नहीं. हियर एमएसबी को माइनस ले दो, ठीक है बस. सो इसका वैल्यू मिलेगा -8 + 2, इसका वैल्यू इज -6. आप नॉर्मल मेथड में करके चेक करो, चाहिए तो आप इसका टूस कॉम्प्लीमेंट बना के चेक करना चाहिए तो चेक करो, यू गेट द सेम आंसर. ठीक है, 6 होता है ना टूस कॉम्प्लीमेंट में. फाइन, बट नॉर्मली आई हैव डायरेक्टली गिवन दिस. हाउ? वंस जो रिपीट हो रहा है ना इसको नेग्लेक्ट करो, साइन एक्सटेंशन बोलते हैं इसको. सो 1 2 4 जो एमएसबी होता है ना हमारे पास, इसको माइनस लगाओ बस. एंड कहाँ पे 1 है तो वो ऐड करो, हो जाएंगे, इसका वैल्यू मिलेगा आपको. ठीक है, आपका बी का वैल्यू कितना, 0 0 0 0 1 0 1 0. ये तो पॉजिटिव नंबर है ना. व्हाट इज इट्स वैल्यू, 10. सो व्हाट इज ए टू बी -16. सो 60 का मतलब क्या, 60 का मतलब इज 32 16 48 48 plus 12. Okay, this is 60, right? 128 64 32 16 8 4 12. 12 plus 48 60 है ना. So -60 क्या होता है सर, अप टू फर्स्ट वन कॉपी एज इट इज एंड बाकी को ले लो टूस कॉम्प्लीमेंट. So this is the answer. So 11 11 0 0 1 0 0. 11 00 01 00. Okay. If you want to know the value of this number, 11 00 01 00 का वैल्यू आपको पता होना चाहिए, तो क्या करना, 1 2 4 8 16 32. If it is repeated, don't take it. Only first one you take, -64. So what is its value is -64 plus another one is 4. You can take -128 plus 64 also, you get the same answer, but I'm making the analysis easy. The repeated ones को neglect करो, केवल first one to be considered. To find the value of the number which is represented in the two's complement, which is the easiest way, I have already explained in the regular class this one. ठीक है? So what is the answer is option A. So guys, इसके बारे में लास्टली डिस्कस करता हूँ. व्हाई लास्टली डिस्कस करना चाहिए, बिकॉज इट इज नॉट प्रेजेंट फॉर इलेक्ट्रिकल इंजीनियरिंग स्टूडेंट्स, इट इज ओनली फॉर ईसी स्टूडेंट्स. ठीक है, और शैल वी डिस्कस नाउ ओनली. ठीक है, हो जाएगा 1 मिनट में. सो दिस क्वेश्चन इज ओनली फॉर ईसी. ओके, ठीक है, लेट्स डू इट नाउ. जस्ट 1 मिनट का काम है, इसके बाद बाकी क्वेश्चन तो सबको हो जाएगा. इलेक्ट्रिकल बच्चों तो आराम कर लो, थोड़े से देर. वीडियो तो अवेलेबल मोटिव सक्सेस. So please try. This is an important model यार. I am expecting this particular year. 2 साल से एक्सपेक्ट कर रहा हूँ, नहीं आ रहा है, इस साल हो सकते हैं. हो गया टाइम. So what is the format? I hope you know. Anybody have done this question? Let me check. Anybody here in the class? Nobody. So many people skip this topic, I feel, because it's the latest edition in the topic. ओके, मैंने डिजिटल कोर्सेज में भी ये टॉपिक तो नहीं मिल रहा है, हमारा कोर्स में तो ये मैं एक्सप्लेन भी किया अच्छे से. सो आई होप यू नो दिस. ईसी पीपल को ये इंपॉर्टेंट है, आने के लिए चांस भी है. ठीक है. सो व्हाट इज द फॉर्मेट वी हैव इज एम. लेट मी टेक वन रेक्टेंगल. The first bit will represent sign bit to 0 high by. Next 8 bits will represent exponent. Exponent is 8 bits 1, 2, 3, 4, 5, 6, 7, 8. So 0, double 1, double 1, 1, double 0. 8 बिट्स हो गया ना 0 ट्रिपल 1 डबल 1 डबल 0 ठीक है. देन बाकी बिट्स जो होता है ना वो मांटिसा ठीक है. डबल 1 0 डबल 1 0 1 ऑल जीरोस ठीक है. ये 23 बिट्स होता है. ये तो 8 बिट ये 1 बिट ठीक है. टोटल 32 बिट्स. दिस इज द रिप्रेजेंटेशन स्टैंडर्ड फॉर्म ऑफ रिप्रेजेंटेशन. Here, what is the sign bit means minus 1 whole to the power of sign. Okay. Next 1 dot m into 2 to the power of 127 minus e. This is the formula. Okay. So what is the e star? इसको बोलते हैं e star. Normal exponent from the biased exponent. What is your e value? E value is 0 triple 1 डबल 1 डबल 0. So 8421 कोड लगाओ तो 64 and 32 16 8 and 4. What is the answer? 96. 96 plus 12. So 96 plus 28. 96 plus 28. 104. 124. Okay, 124. So this will be 127 minus 124. That will give you 3. 1 minute, 1. I gave reverse. E minus 127. E minus 127. So E value is 124 minus 127. Because while writing, we do biasing and add 127. So it is minus 3. So what is your Mantissa value? Okay. 1. Okay. What is your 1 dot m value? 1.1 into 2 power minus 3. That is the final answer. 1.1101101 into 2 power minus 3. So if you have calculator, this is in the base. Just a moment. Just a moment. Let me do the calculation. So this value will be 0.00011101101 in the binary. That will give you 0.228. Calculation I am not doing here. You can check in your calculator. You get 2.28 into exactly 2.27 something you get 10 power minus. Okay, 2.28 nearly 2.27 nearest closest he asked. See, if you have not studied this concept, you feel it is as completely strange. Already you have studied this, then I can explain you. So what is that? Sine exponent mantissa is the formula. Sine is 0. Exponent is the first 8 bits after the first bit, and mantissa will be the remaining bits. So whatever you have here, that you should take it in the form of, we call it as a normalized representation. 1 dot this number and into 2 to the power of whatever the exponent you are getting it will be subtracted from 127, because while representing we add 127 and represent. So while getting its value, you should do this biasing. So subtract from minus x is 127 representation, this one is. So subtract from my 127, you get minus 3. So the value of this will be equal to 1 dot that particular number into 2 to the power of minus 3. So 2 to the power of n से कोई भी binary number multiply किया तो it will be added n number of zeros, or dot will be shifted n sides. So here it is minus 3, no? So it is shifted this side. So you get 0 0.1, 0 0.01, 0.001, 111, this one. So this, if you do the calculation and add it, you get 0.228 or 2.28 10 power minus 1, approximately equivalent to 2.27 10 power minus 1. So electrical बच्चों इसको छोड़ दो, only for EC this one, only for EC. ठीक है, let's go for the next. I'm expecting this model यार, बहुत दिन से वेट कर रहा हूँ, because this is added in 2021 syllabus, नहीं दिया 22 पे, नहीं दिया 23 पे, at least I feel that they may give it. Okay, so that's why I have added. So next question is ready for you guys. Let's start. So this PDF I'll upload in my Telegram channel in 2-3 days here. That is Shankar 10 is my Telegram channel. It is not okay if you leave EDC, ADC and DAC इलेक्ट्रिकल बच्चों, आपका चैप्टर से 3 है ना, इसमें एक चैप्टर छोड़ दिया तो क्या प्रिपेयर करेगा आप लोग? डिजिटल पे हार्डली आपको 3 चैप्टर है भाई, कॉम्बिनेशनल सीक्वेंशियल डाटा कन्वर्टर्स, इसमें डाटा कन्वर्टर्स छोड़ दिया तो इट इज इक्विवेलेंट टू लीविंग द सब्जेक्ट कंप्लीटली. यू डोंट नो, हार्डली 2 क्वेश्चंस में कम फ्रॉम द डिजिटल फॉर इलेक्ट्रिकल इंजीनियरिंग. इसमें क्वेश्चन तो कंपलसरी आने के चांस है डीएससी डीसी से. ठीक है, सो 17 seconds more. Many electrical engineering students make this mistake here. This is 100% scoring subject, not even 90% I am saying. Full marks you can score from this subject. Okay, so don't miss this. Electrical बच्चों को relatively easy paper आएगा compared to EC people, and you can score full out of it. So don't leave any topic in this subject, guys. So for the logic circuit shown in the figure, what is the output? Y. So whenever the gates are given like this, हम तो हमारा regular class में भी discuss किया, send the bubbles backside. How to send the bubbles backside, sir? Convert the NOR gate into bubbled AND gate, and this NAND gate into bubbled OR gate. हो गया question? ठीक है? Bubble cancels. ठीक है? So here, what do you get? And I feel that this is not, need not be done. This we can keep it as it is. Why you keep as it is, sir? Because there is no cancellation of bubbles here. So you will get A here, C here. What do you get here? AB, VC. What do you get here? AB into VC will give you ABC. So what do you finally get? ABC whole bar. Because A into ABC into C will be ABC only, whole bar you will get. So option A is the right answer. But option A is not the only right answer. How many of you gave option A? Option A to galat hai bhai. Keval option A is not the answer. You see, AB bar plus VC bar, AB into VC whole bar by De Morgan's light is also right answer. AB plus BC AC. Okay, multiply all of them, take the whole bar, you get ABC whole bar. Okay, right? All of them are right answers. So don't take ABC, you should take option A or B or C, or you should take all of them. So 5 questions are completed, 20% of your class is done. So let's move for the next question. Okay, many people have done this mistake, and that's why always you should read the question carefully, and also the options. Every single option you must read all the options. Then only you will get the clarity. Don't see the first option. अरे sir मेरे को answer बताया है ये भी whole बार गलत है भाई. चलो next question. This is also based on the logic gates only. Chalo, give it a try. Next question, please try. So 20 seconds, 28 seconds, 27 seconds more. Give a try. For the output F to be 1 in the logic circuit shown, the input combination should be A, B, C क्या होना चाहिए? 4 seconds में. Question number 6. Option D, a right answer. Okay, चलो. Here you observe मेरा input क्या है इसका A XOR B. Here A XOR B. Okay. Suppose if you take here X, here it will be X bar. And ये दोनों क्या होता है भाई मेरा यही पे आइदर 0 1 आएगा नहीं है तो 1 0 whatever may be AB is 0 0 0 1 1 0 1 1 it doesn't matter whatever may be the input here will be always X and X bar format because this is AX or B, this is AX or B, so your output is not depending on A and B if you observe carefully. AB can be anything, whatever you get here will be either 0 1 or 1 0, either 0 1 or 1 0. So this will be giving you 0 1 or 1 0. So C will decide your answer. So here AB doesn't matter, AB doesn't matter. C सभी cases में 0. So take them wrong. Here C is different. Take it right. अरे सर ऐसा क्यों कैसे लेते हैं सर? सर C 0 पे भी आंसर राइट हो सकते हैं ना सर? नहीं. Listen here. Here when C is equal to 1, what are the inputs for the 3 input exclusive NOR gate? Here you get 0 1 or 1 0. Okay, if C equal to 0, okay, or C equal to 1, your input contains even input का मतलब A B C नहीं भाई, ये तीनों input यही पे जो आ रहा है ना ये input even number of ones, output equal to 1. This is a complement of XOR. Okay, this is A XOR B XOR C का complement. But you know XNOR के लिए दो implementations है. In one sense, this is also correct. Suppose if you give 0 here, you get even number of zeros. In that case also, it can be 1. When will you get that is when you implement XOR in this way. XNOR का output में दूसरा XNOR लेके implement किया तो here what do you get? Even number of zeros, output equal to 1. This difference, when to apply which particular, some textbooks or some IEEE representation papers will follow this. They will say that three input case mein XOR and XNOR are same. And some people will say that XNOR is completely complement of XOR. This is represented by, made with the help of XOR gate, output में एक inverter. ठीक है. In that case you get even number of ones, output equal to 1, but here even number of zeros, output equal to 1. Both are different representations of XNOR according. Okay, I think this is fine now. Okay, please close and open. Okay, it's working fine now. Right. So I am repeating this. I don't know when it stopped properly. So see here for the function f to be 1. Here you observe if it is ax or b, it is ax not b. So they are complementary to each other. यहीं पे x ले लिया तो यहीं पे compulsory x bar होता है. So x may be 0 or 1, I don't know. X and x bar are always complementary. So here 0 1 or 1 0 will come. This is fixed. So output will be depending on C. AB can be any value. Output is not depending on AB. So in all the cases, C is 0. Here C is 1 because it is independent of AB. Output is depending on C only. If C equal to 0 may you get right answer, then all these answers are correct. So compulsory C equal to 1 is the right answer. Now I am cross checking. So AB can be anything. Your x and x bar will be either 1 0 or 0 1. C पे 1 लगाएंगे तो आपको क्या मिलेगा? You get even number of ones here. When you get even number of ones, XOR output equal to 1, provided XOR is the complement of XOR. If it is represented by taking XOR and taking its complement. There is another way to represent XOR is even number of zeros may output equal to 1. That is possible when XOR is made by output of 2 input to another 2 input. I explained both of them in my regular class. Okay. Which one is to be applied in the exam means it depends on options available. To be frank, this is also correct because in IEEE papers, etc., they will treat three input XOR and XOR as same. I have seen some papers. Okay, some books will follow that XOR is complement of XOR for all number of inputs. Order even doesn't matter. So it depends on the options elimination. We should go. So option D is satisfying. So in this case, examiner has taken it into consideration. Input contains even number of ones. Output is one. Input is not ABC. Input is this 3 bits. Okay. Chalo. Next question. So in the K-map shown in the below, minimal output X, just K-map का minimize करना चाहिए भाई. Options, question number 7. Question number 7. Last 25 seconds. Give an answer. Give your try. Give your answer. Option B. Chalo. So in the K-map shown, the minimal output X. Yeah, simple way. This is a quad, another quad, and a pair, right? So what is the answer? A bar B and this one. Okay, for this it is BC bar, and for this it is A bar C, right? A bar B, BC bar, and A bar C. Next question. This model most frequently occurred. Now we entered into the new chapter, that is now the real electrical engineering syllabus enter ho gaya, that is combinational circuits. Okay, so let's start. Combinational circuits में adder का question है, most stock question, regular question, easiest question. Okay, so give a try. So there can be a question from adders. It may not be this much easy, but there can be a question from the adders compulsory. So give a try. If you couldn't prepare, see here, first start preparation. What can I suggest if you don't prepare anything from the digital? पहले मेरा क्लासेस देखो, मेरा क्रैश कोर्स अवेलेबल है यूट्यूब में. नहीं है तो प्लस में भी मेरा कोर्सेस है. So don't directly follow. So electrical engineering के लिए मेरा suggestion तो ये है, many students will commit this mistake. They have the syllabus में combinational circuits as the starting part. So they don't study number system, they don't study Boolean algebra. They think they are wasting their time. But until unless you study them, you cannot understand the other chapters. Okay. So start, if you want to study digital compulsory, you should start from number systems only. Don't start from what we call combinational circuits or sequential circuits. In YouTube, I have done complete courses available. It is in the name of crash course. So what is the formula for the total delay here? Whenever inputs are not specified, internal circuit is not given. In those cases only you can apply this formula. If internal circuit is given or inputs are specified, then according to the figure, according to the inputs, we should apply that particular condition. Don't apply this formula. But here, when the inputs you don't know and the internal circuit you don't know, then you can use n minus 1 times carry plus maximum of sum and carry. So n is 15. Sorry, n is how many bits? 16 minus 1 times carry. Carry is how much? 15 nanoseconds plus maximum of, sorry, carry is how much? 12 nanoseconds. Maximum of 15 and 12. So 180 plus 15, 195 nanoseconds. Okay, 195 nanoseconds is the right answer. Next question. So marks का questions तो बहुत important है. That is for electrical and ECE students. Every year marks से questions तो compulsory आ रहा है. Every single year you see any previous year paper, marks का question, बिना marks का question, there is no question paper. You can just check it. Right? So give a try. See, because you are 23 aspirants, digital subject will not change. You cannot learn it in 10 hours. Okay, if you are 24 hours, 24 aspirants or 23 aspirant or 22 aspirants, subject to same year by. So it doesn't matter. There is no way you can learn in 5 hours or 10 hours. It will waste just your time, but you'll not able to learn in a proper way. If you want to learn proper way, definitely you need a time. So check some crash course or notes. If it is helpful, you can give a try. But I don't think it is possible. Okay, these are the subjects where you get a full score. I don't know many electrical engineering students who don't prepare it from the beginning. At the end, they will come and they say, "Arey sir, I haven't prepared digital circuits abhi tak." Networks, digital signal control, जो subjects होता है ना, those are the scoring subjects for you. Never, don't skip these subjects in your preparation. This is the blunder done by many students in 2022. आप लोग भी कर रहे हैं. I don't know from where you got the guidance to start this subject at the end. आप लोग ये वाला subjects जो है ना, these are the subjects where you need to start your preparation. So time up हो गया. So चलो. So 2/1 marks है ना, इसका expression क्या? So check some crash course or something if it is helpful in try to learn in 2x mode, whatever possible you can give a try. So S bar I naught, that is y bar into x bar plus s into I1, that is the characteristic equation of 2/1 marks. So that is y into x. So sir, it is nothing but y x nor x. Okay. So here what is that? Here suppose you have s. So just write with respect to s. Okay. So s bar into what is that? S bar into z bar plus s into z. Okay. So this is what we call s x nor with z. So this is y x nor with x. You should take a bracket x nor with z. Don't take so this is equal to sum of the min terms 1247 as a standard form. Okay. So what is this? X nor with y, x nor with z. Okay, x nor with y, x nor with z is the answer. It is also equal to x XOR y, X or Z. You check it at home if you want. Both will give you same answer. But you should do X nor Y first. Suppose you are having the X, Y, Z, all zeros to all ones. Okay. And write the output F. You check it. Okay. First you do X nor, then do X nor. You check what is the answer. 0 X nor with 0 is 1. 1 X nor with this one, 0. 0 X nor 0 is 1. 1 X nor with 1, 1. Like that you get. 1 X nor with 1, 1. X nor with 1. You try this at home. Okay. Right. So this is the answer. Next. Again the next question, the 10th question. I'll try for electrical engineering students. I have seen many students are saying like this. So 10, 15 hours I'll plan one course in this month. Uh, I'll try. If possible, I'll take some crash course of digital also for you. Right. It is the right answer. Here, one simplest way to do this is here when Wx is 0, 0. Okay. Firstly, when will you get the output? The output is equal to y. Okay. So similarly, when Wx is 0, 1, the output is 0. For 1, 0, output is z. For 1, 1, your output is 1. Okay. So fine. So here you see when you have yz, they can be 0, 0, 0, 1, 1, 0, 1, 1. How many times y is equal to 1? 2 times. Here 0 times. Similarly, here also, if you take yz, it's 0, 0, 0, 1, 1, 0, 1, 1. Z equal to 1 2 times because output is same as Z now. When Z equal to 1, you get output equal to 1. So here 2 times was. Here yz can be anything 0, 0, 0, 1, 1, 0, 1, 1. Doesn't matter. All the possible cases may Wx is equal to 1, 1. You get the output is equal to 1. 4 possibilities are there. Total how many possibilities are there? 8. You can also do by taking a K-map and solve it. You get the same answer, no doubt in it. ठीक है? So चाहिए तो थोड़ा छोटी वाला K-map ले रहा हूँ. So WXYZ. When WX is 0, 0, 0, 1, 1, 1, 1, 0. K-map ले लिया. So WX 0, 0 में मेरा output is Y. Here 0. 1, 1 में मेरा output is 1. 1, 0 में मेरा output is Z. So 0, 0, 0, 1, 1, 1, 1, 0. So here, what is my output is same as y. Y का value देखो 0, 0, 1, 1. Here my output is 0, but here my output is 1. Here my output is same as z. Z का value देखो 1. So here, how many times it is coming is 8 times. Sorry, in this way also you can analyze both the ways आपका answer तो same. I'll try in YouTube only, Sona. Okay. ट्राई करता हूँ मैं. आई एम नॉट गिविंग यू द एश्योरेंस. एक बार मैं चेक करके कितना लोग आती है पता नहीं मेरे को. सो बेस्ड ऑन दैट आई विल टेक ए डिसीजन एंड आई विल डू दैट. ओके. Maybe in 2 3 days I'll start if I decide. Okay. Chalo, next question. It is also based on mux only, so give a try. आंसर दे दो भाई, कितना टाइम लग रहा है? हाँ, ठीक है, आई शुड ओनली डू इट. दिस इज x y z. So first one is 0 1 है ना, x bar, I mean I naught is 0, I1 is 1. So x bar into 0, x into 1. You get x as it is. Here also x. Here you have given y. Okay. So here you get y. Whatever may be the input, you get output equal to x only. Na? Y equal to 0 or 1, whatever may be, your output is y. If y can be anything, you are getting x only here. So now what is the output you get? This is I naught and I1. Okay. So z bar into y plus z into x. So the answer is xz plus uh, xz plus yz bar. ठीक है. So xz plus yz bar का what we call canonical form में किया तो x yz plus x y bar z. Y missing है ना, मैं y bar add किया. X y z bar plus x bar y z bar. Here x missing, मैं तो x bar add किया directly. 1 1 1 1 0 1 1 1 0 0 1 1. So sum of the midterms 3 5 6 7. 3 5 6 7 पे 2 5 6 7 क्यों आया? हाँ y z bar है ना. Option C is the right answer. Very good. Bonexually right answer. So ठीक है भाई. Here I not I1 उल्टा किया एग्जाम्पल. Here I not I1. Here I1 I not दिया. Here I1 I not दिया. ठीक है. So what is the characteristic equation of mux is S bar into I not plus S into I1. So x bar into 0 plus x into 1 x. ये भी x. So y bar into x plus yx तो x ही होता है ना. Whatever may be y, you are getting x only. So x and y here. So z bar into x plus zy. That I have converted into canonical format. Chalo. Next, let's move. The next question. It's an adder question again. Here, consider an 8-bit binary ripple adder for computing the sum of A and B, where A and B are integers represented in the 2's complement format. If the decimal value of A is 1, okay, A is equal to 1, 0, 0, 0, 0, 0, 0, 0, 0, 1. Then what is the decimal value of B? That leads the longest latency. Latency का मतलब ज़्यादा time लगेगा. कौन सा वाला input में आपको ज़्यादा time लगेगा? So which input will take more time while doing the addition is B equal to 1 1 1 1 1 1 1 1. Because इस case में क्या होता है ना? So first you should do the addition, you get the sum and carry next को लेते देते हैं. इसके बाद ये दोनों ऐड करना, फिर कैरी यहीं पे देना, ऐड करना कैरी देना, ऐड करना कैरी देना, ऐड करके कैरी देना चाहिए. ये प्रोसेस तो कंटिन्यू होके यहीं पे आउटपुट आना चाहिए. इसमें बहुत ज्यादा टाइम लगेगा. सो व्हाट इज इट्स वैल्यू? बी इक्वल टू डबल वन डबल वन डबल वन डबल वन. सो इट्स वैल्यू इज इक्वल टू -1 इन द डेसिमल. ठीक है. -128 164 32 16 8 4 2 1 ऐड करो. नहीं है तो टूज कॉम्प्लीमेंट लेके चेक करो. सो -1. Okay, the decimal value of the number b which takes more time. Suppose you take other integer, for example, check कर लो यार. Here, sir, I will take 0010 sir. ज़्यादा टाइम नहीं लगेगा ना. 1 1 हो गया काम. बाकी पे ऑलरेडी इस पे रिजल्ट पे अवेलेबल है. कम टाइम पे हो जाएगा. सो ज़्यादा टाइम कौन सा लेती है भाई? ऑल वंस. ठीक है. चलो. So we are in the middle part. Half of the questions were done. How much time? What's the time? Almost 1 hour ले लिया. ठीक है, लेस देन 1 hour पे हो गया ना, 55 minutes. ठीक है, one so 50 minutes more we will complete this. So the 13th question, when two 8-bit numbers are added, that is A7 to A naught and B7 to B naught in the two's complement representation, with A naught B naught will be the LSBs are added using the ripple carry added. The sum is given by the result is S7 to S naught and carry bits are C naught to C1. Overflow is said to be occurred if the carry bit C7 is 1, all the carry bits are 1, A7 B7 S7 bar or A7 bar B7 S bar S7 is 1, or A naught B naught S naught bar A naught bar B naught bar S naught is equal to 1. What is the right answer? It takes time to read the question, but once you read, you can answer it easily, provided your concepts are very clear. देखो आपका इलेक्ट्रिकल वाला बच्चों को सिलेबस में ऐड रहे कॉम्बिनेशनल सर्किट, नंबर सिस्टम्स तो नहीं है, बट बिना नंबर सिस्टम हाउ कैन यू अंडरस्टैंड दिस? ओवरफ्लो वाला कॉन्सेप्ट तो वी स्टडी इन द नंबर सिस्टम्स, वी अप्लाई इन द कॉम्बिनेशनल सर्किट्स. So please understand, it is very important to read number systems and Boolean algebra to understand properly the digital circuits of combinational, sequential and other chapters also. Chalo. So when will you get the carry? Is when two positive numbers are added, that is A7 is a positive number, B7 is a positive, because A7, B7 represents the sign of the number. If they are 0, 0, and the result you are getting, okay, when two positive numbers are added, if you get a negative number, that is S7 equal to 1, that is, or another possibility, kya? Two negative numbers are added, A7, B7 are negative, but the result is positive. In both the cases, you get the overflow condition. Okay, so two positive. This is the sign bit of the both numbers. Two positive numbers. Result का sign क्या? Negative. Or two negative numbers. Result का positive. It is not possible to get a positive result with the negative numbers. और negative numbers add किया तो positive result नहीं आ सकते. और positive numbers add किया तो negative number नहीं आ सकते ना. That is the condition of overflow where you need to extend the number of bits by considering the carry without neglecting the carry. So the next question is ready for you guys. Consider the following multiplexer where you have I0 to I3, 4-bit 4x1 multiplexer. A1, A0 are the selection input, En is the enable input. What is the function implemented by the above circuit? Chalo, ready. So please try. X, Y, Z. Time up. Time up. Here first thing we should understand is मेरा enable 1 होने के लिए मैं तो compulsory क्या होना चाहिए, यही पे 1 आना चाहिए, यही पे 1 आना चाहिए तो ये 0 होना चाहिए. So ये not is always 0, इसमें कोई change नहीं, ठीक है. Then here xy can be anything. So here if you take a1 a0, okay, a0 is permanently fixed to 0, a1 is connected to y bar. When y equal to 0, you get, or y equal to 1, you get y bar is 0, and y equal to 0, you get y bar equal to 1. So 0, 0, 1, 0. What is your output? You should, your output is equal to 0, 0 में I naught, here I2. So I naught and I2 will be selected when y equal to 1 and y equal to 0. So what are your I naught and I1? I naught is x. I2 is how much? Y. Okay. So see here, what is the expression? When y equal to 1, your output is equal to x. So you can write it as xy. When y equal to 0, y equal to 0, your output is y itself. So y equal to 0, your output is y. That is, it is 0 only. So your output expression is x into y if z equal to 0 compulsory. Why z equal to 0 होना चाहिए sir? Because to enable the system z must be equal to 0. So I can say x into y into z bar is the expression. When z equal to 0, you get output is equal to x, y is the answer. ठीक है? Right? So this is how you write. नहीं है तो एक normal method से भी conventional method तो ये होना चाहिए z bar common ले लो. Then s1 bar, s0 bar. This is y bar ना. This is z ना. So you should write one by one. Okay. You already know this is to be 0, but normally लिखना चाहिए तो ऐसा होना चाहिए. Z must be 0. So z bar common ले लो. इसके बाद क्या होना चाहिए 0 0 में? That is y bar, a1 bar, a0 bar na, y bar whole bar into z bar into x. Next, what is that? A bar b, that is y bar whole bar into what is the second input? Z into second input x. Next, third input a1 a0 bar, a1 is y bar into a0 bar into what is that? Third y plus a1 a0. What is a1 a0? a1 to y bar z into I3. I3 is equal to y bar. In this way also you can do. But after that z bar and z cancels. Okay. Y bar and y cancels. Z bar and z cancels. So z bar into z. Final answer to x, y, z bar. Any method will give you same. This is the conventional method. This is the logically you can do it. In any way you do, your answer will remain the same. Okay. If you remember the Mux expression, you can solve it. Chalo, next question. It is a sequential circuit's first question. If it is not properly visible in the circuit shown in the figure, the switch is momentarily closed. Okay, a switch जो है ना, this is the circuit given. एक इन्वर्टर का आउटपुट में, एक और 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 इन्वर्टर लगा के y, x and here 1 switch is momentarily close करके open किया. ठीक है? Assuming the logic gates are having all of them are having some non-zero propagation delay, what is the steady state output? Okay, of x and y. यहीं पे मैं एक बार 1 देके open किया. Then what will be what you will get at x, what you will get at y in the steady state. They will toggle, they will be 0, they will be 1, like that. Okay, so मैं options देना चाहिए तो देता हूँ. They will toggle. Option B 0 0 1 1 0 1 1 0. Good. No answer है. Okay. चलो यहीं पे एक बार इनपुट देके चेक करो यार क्या दिक्कत है. If you give 0 after some propagation delay you get 1. But 1 will come after propagation delay 0. 1. After delay you get 0. Okay. And after delay it will become 1 again. And this will become 0 and 1, 0, 1. And this process will repeat. So, because n is equal to odd, it is an astable multi-vibrator. You take the output at x or output at y. In any case, the output will be toggle. It will be like this: 1 0 1 0 1 0. Right. Next question. So, question number 16. So, in the circuit, you have a Mealy state diagram. You need to find x is the don't care. Okay. So, what is the output? Simple question. Both simple question. Very simple question. So question number 16, 9 more questions more. What is this? Asan question hai bhai. Listen. According to this figure, whenever your input is 1 1, your output is 0. Okay. And for 0 cross का मतलब क्या? 0 0 and 0 1. 0 cross का मतलब क्या? 0 0 0 1. Means it can be is presently at A state or B state, doesn't matter. When the input is 0 0 or 0 1, your output is 1. For 1 0 also output 1. So input is 0 0 0 1 1 0 1 1 में output is how much? It is all cases में 1 except 1 1 output equal to 0. 1 1 में output is equal to 0. Okay. So what is this? It is nothing but NAND gate. So this is the what we call the state diagram of NAND gate. You can draw the state diagram of flip flop, etc. Also, their output depends on the previous value. Here output is same for the particular given input. Output is same. It doesn't depend on which particular state it is. If already A is 0, output is 0. Whenever you give 0 0 0 1 1 0, it will become 1. Whenever it is 1, 0 0 or 0 1 or 1 0, it will stay at 1. But if you give 1 1, it will go to output equal to 0. Good. Harsha and Vanya right answers. So next question. So minimum number of JK flip-flops required to construct a synchronous counter with a counting sequence of 0 0 1 1 2 2 3 3 and again 0 0. So understand here, you need to make 0 0 0 1 1 2 2 3 3. So for 2 clocks it should be 0. What happened? I'm not visible. Just a moment. पता नहीं क्या हुआ। हाँ मैं तो देख लिया, ठीक है, स्टेबलाइज हो गया। राइट। So in the minimum number of JK flip-flops required to construct a synchronous counter to count the sequence. What is the answer यार? स्क्रीन तो ब्लर है, ठीक है, हो गया। अरे यार स्क्रीन ऐसा क्यों हो रहा है बार बार? कुछ अपडेट करना चाहिए मेरे सिस्टम को, ठीक है, I'll do that later. Now tell me the answer. Question number 17. What is the answer? Okay. So generally you can do 0, 1, 2, 3 is a mod 4 counter, log to the base to 4, you say 2 flip-flops. बट यही पे 0 2 टाइम्स आना चाहिए, 1 2 टाइम्स, 2 2 टाइम्स, 3 2 टाइम्स आना चाहिए, ऐसा करना चाहिए। इस केस में क्या करना चाहिए सर? थोड़ा सा कॉमन सेंस यूज करना चाहिए। यू कैन डिजाइन लाइक दिस, you can use one frequency divider circuit which divide your input frequency to half, then every two clock pulses में only one clock will go to the counter and it will count 0. After counting 0, I should stop the count for 2 clock pulses. So original clock, suppose this is the clock, if I convert this into this kind of clock, okay, so this is called frequency divider circuit, then नॉर्मल काउंटर से हो जाएंगे, बट फ्रीक्वेंसी डिवीजन के लिए आपको एक फ्लिप फ्लॉप चाहिए प्लस 2 फ्लिप फ्लॉप, 3 फ्लिप फ्लॉप, बट परफेक्ट सिंक्रोनस डिजाइन भी करना चाहिए, तो आई विल शो यू। दिस इज वन मेथड, ओके, दिस इज द क्लॉक, this is the clock to counter after frequency division, then it will do it, nahi hai to listen carefully, 0 2 times, 1 2 times, 2 2 times and 3 2 times के लिए you can do like this, 0 0 1, okay, now carefully observe, carefully, so you read only these two bits, so normal clock 0, this is one method, first clock, second clock, third, fourth, 5 6 7 8, so this is your output of the count. We don't take all the 3 bits. We take 3 flip flops, but we take only these two as your counter outputs. Originally, this is your flip flop, but I use only these two. Okay? Cubic QA. Okay. Bus. So 3 flip flops are required. Very good. Next question. Similar model question. You have a mod 3 counter. You need to find a QAB sequence. After how many clock pulses? 3 clocks. So after 3 clock ticks, what is the output? That is the question by examiner. So 30 seconds more. Okay. So 110. Let's try. So the figure initially Q, A, B, all zeros. Okay. After three clock triggers, what is the output? Okay. So Q, A और B और clock. Clock zeros सारे zero से है. Clock 1, 2, 3, 4. So every clock pulse, this is a toggle flip flop, so it will toggle, 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 toggle. Actually, he should show properly. So मैं zoom कर रहा हूँ. It is a positive edge triggered flip flop. So this is given as the clock. Na? When the positive edge of the clock occurs, the counter will proceed further. When the positive edge of the clock occurs, the counter will proceed further. Okay? Do you understand what I am saying? During the positive edge of Q is changing from 0 to 1, then it will count the next. Again, this is because Q is the clock input here. Na? So when Q is changing from 0 to 1, I assuming as a positive edge trigger, nothing is specified. So next count. So what is the answer is 110. Right answer 110. Next. अच्छा थोड़ा सा लेंदी क्वेश्चन आया. Have patience to read the question. Okay. In the circuit below, the light dependent resistance, अरे यार op amp भी है सभी है. So in the circuit, the light dependent resistor receives light. Let me read first. लाइट डिपेंडेंट रेसिस्टर कहाँ पे है? यही पे लाइट एलईडी से मिल रहा है. ठीक है. एलडीआर हैज अ रेजिस्टेंस ऑफ 5 किलो ओम. ओके. क्या दिक्कत है? एंड 500 ओम अंडर डार्क एंड इल्यूमिनेटेड. ओके. लाइट इसमें गया तो इट विल गिव यू 500 ओम्स. इल्यूमिनेटेड का मतलब डार्क मीन्स ये लाइट नहीं आएंगे तो 500. ठीक है यार, कोई दिक्कत नहीं. The LED is off initially for time t less than 0. Okay, at time t equal to 0 seconds, the switch is open. Switch is closed for 1 millisecond. ये तो close किया मैंने 1 millisecond and then kept open thereafter. Assuming there is no propagation delay in the devices, the LED will turn on when such switch 1 is closed and remains on after S1 is open. And LED will turn on when S1 is closed and turns off when S1 is open. Turns on when S1 is closed and toggles periodically from on to off after S1 is open. Remains off when S1 is closed and continues to remain off when S1 is open also. ये पूरा जिंदगी तक ऑफ ही होता है बोल रहा है. ठीक है. नहीं तो ये टर्न व्हेन S1 इज क्लोज्ड. ठीक है. S1 क्लोज किया तो इट विल ऑन एंड आफ्टर दैट periodically from on to off after S1 is open. Right. Let's see what is your answer. सही है ना क्वेश्चन? क्वेश्चन देख के डर मत होना चाहिए भाई. ठीक है. पेशेंस चाहिए टू रीड द क्वेश्चन. टाइम आउट. एनीबॉडी गॉट द आंसर? Answer is not on because anyway he has not given any propagation delay, so don't worry. But if by chance, okay, the moment you open the switch, if some voltage come here, I mean, if the LED is off for a moment, at that time you get 5k here, 1k here, 5k, 1k combination में आपका here this node voltage will be less than 1 volt, but in that case you get that 1. 1 is going to the SR NAND latch is unchanged. Your output once becomes 1 0 because it is permanently 1. Here you get 0 1 or 1 1. It will remain the same output. Okay. So the transfer will be permanently on and the LED will be on. So what I want to say, so it will turn on when S1 is closed and toggles periodically 9. It turn on when S1 is closed and turn off when S1 is open. No. Turn on when S1 is closed and remains on when S1 is open also. This is the right answer. Option A. Okay. क्या दिक्कत हुआ यार आजकल बफर क्यों हो रहा है अभी तक मेरा क्लास में इश्यू नहीं आया यस इन क्लास तो मैंने डिस्कस किया मेरे हिसाब से सो एवरीबॉडी इज इट क्लियर एनी डाउट प्लीज आस्क मी थोड़ा सा आपको एनालॉग चाहिए नेटवर्क चाहिए डिजिटल का बेसिक भी चाहिए इट इज द क्वेश्चन विच कंबाइंस ऑल द कॉन्सेप्ट्स इज इट ओके कैन आई प्रोसीड फर्दर प्लीज रेस्पॉन्ड या shall we move for the next question yeah that is always important patience तो हमेशा चाहिए ठीक है पेशेंस टू रीड द क्वेश्चन रीड द ऑप्शंस उतना तो होना चाहिए ठीक है सो शैल वी प्रोसीड थैंक यू लास्ट 5-6 क्वेश्चंस इसके बाद 5 क्वेश्चंस है सो दिस ईयरफोन इज इरिटेटिंग yes last chapter of our discussion that is data converters अभी तक हमने क्या sequential का questions किया combinational का किया boolean algebra का किया number systems का किया now the last 6 questions I kept are from what we call the data converters this is the largest question remaining all questions तो आसान है this model का question भी हम regular class में किया so please give a try you have a 16-bit DAC implemented using two 8-bit DACs as shown in the below. The resolution of the second DAC is R2, which is 2 times the resolution of the first DAC. What is the value of Rx required and also the resolution of the second DAC, 16-bit DAC? थोड़ा सा लॉजिकल क्वेश्चन अदरवाइज ऑप्शंस चाहिए क्या आपको where R1, R2 are the resolutions of the first and second DACs, right? So this is the logical question. I made this question. I have personally made this question based on one previous year question. मैं तो थोड़ा सा modify करके मैंने किया. Let me check if anybody can able to answer this question. मेरा own question है. Uh, 7 seconds more. 2 seconds more. हो गया टाइम क्या हुआ Okay, I'll tell you. So this is V1. Wait, what is your V naught? Minus the common label, V naught equal to minus into 64K by Rx into V2 plus 64K by 64K into V1. So that is minus common yellow. Okay. 64K by Rx times V2 plus V2. So what is the multiplication factor I need here? I need here is here 2 power 0 to 2 power 7. Here 2 power 8 to 2 power 15, the bit should be multiplied. But originally, it doesn't know that you have given 8th bit. Na, it will normally multiply with 2 power 0 to 2 power 7 only. But I should do 2 power 8 to 2 power 15. To get that, this multiplication factor must be 2 power 8. But already resolution is 2 times. So because of that, you should divide with 2. And the multiplication factor is 2 power 7. That is how much? 2 power 7 ka matlab. 2 power 7. One 128. Huh? So the multiplication factor I need is 128. So 64K by Rx equal to 128. So Rx equal to 0.5K. And the resolution will be R1 only. So R1. Sir, I don't understand the solution. I don't understand the question at all. I can say, see, this is the shortcut method. Many people may not be able to understand. Don't worry. I will do the same question with a proper explanation. Don't worry. Let us see. So let's do it again. Sure. Listen to me. I'll do it in a proper way. Don't worry. So here, you understand your V naught is equal to V naught equal to what? Minus 64K by Rx into let's take this as V2, this as V1. V1 plus V1. Okay, इतना तक सही है ना पता है ना आपको R2 by R1 into this. So what is your V2 and V1? What is your V1 is okay resolution into decimal equivalent. That is R1 into 2 power 3 V3 2 power 7 D7 to 2 power 0 into D naught. Okay. What about V2? V2 equal to same resolution into decimal equivalent. But that resolution here is 2 times R1 because the resolution of the second DAC, okay, R2 is equal to 2 times the resolution of the first DAC. So 2 times R1 into 2 power 7 D15 to 2 power 0 into D8. But here, because the inputs are D8 to D15, but originally DAC will do D0 to D7 only. It doesn't know that you have given D8 here. So if you take these two inside, R1 into 2 power 7, it will become 2 power 8 into D15, 2 power 1 into D8. But I need, okay, we need, it should be 2 power 8 into D8. And here 2 power 15 into D15 is required condition. So इसके लिए what is the multiplication factor? So multiply by 2 power 7. So this should do that part. That should be 2 power 7. Understand what I am saying? If I multiply this with 2 power 7, this will become 2 power 15 and 2 power 8 and it will do my job. Then what I need to do is, so that is 64K by Rx. from the Rx is equal to 0.5k. Okay, that is done. And after getting the expression, you see what is the common you can take is R1. So the resolution, final resolution is equal to R1. Okay, because the expression is with respect to R1, right? Okay. So if you are able to do this question, your digital is very good. EC बच्चों तो करना चाहिए, right? इतना level का questions. हमारा class में regularly we will do this kind of questions. I hope you know. So this is the level of my class questions. चलो, let's move for the next question. ये बाकी questions तो आसान है, आप लोग कर सकते हैं. You can do it. Let's try the last 5 questions of the class. सो यहीं पे मैं शॉर्टकट में देख के हाउ टू राइट टेल द आंसर मैंने बताया हियर एक्सप्लेन्ड इन अ प्रॉपर वे whichever is useful you can go for that. So try this. Try it. Come on. The simplified block diagram of 10-bit ADC of the dual slope ADC is shown in the figure. The 10-bit counter out at the output is clocked by 1 megahertz a clock. Okay, assuming negligible timing overhead for the control logic, the maximum frequency of the analog signal that can be converted using this ADC converter is. Come on, you can do. ओके अरे यार इतना टाइम क्यों ठीक है टाइम उल्टा कर कैलकुलेट कर रहा है एनी गुड आंसर ओके लेट मी एक्सप्लेन क्या हुआ सिंपलीफाइड ब्लॉक डायग्राम ऑफ 10 बिट 4 बिट so 10-bit ADC of dual slope integrator shown in the figure, the 10-bit counter at the output clocked by 1 megahertz assuming negligible overhead means इससे ज़्यादा time extra time कुछ नहीं. That is the meaning of overhead. Don't worry, the meaning of overhead देख के many people will stop reading this question. Okay, the maximum frequency of the analog signal that can be converted. Firstly, find the conversion time. And dual slope ADC में conversion time is 2 power n plus 1 times the time period of the clock. So 2 power 10 is 2 power 11 into time period of the clock is 1 microsecond. So that will give me 2048 microsecond, approximately 2 milliseconds. Approximately. So the conversion time is 2 milliseconds. The sampling time should be greater than 2 milliseconds. So the frequency of the sampling should be less than 1 by 2 milliseconds. That will give you 500 Hz. But the answer is not 500 Hz. Okay. The analog signal frequency he asked must be less than or equal to Fs by 2. Sampling frequency by 2. That will be 250. That is what we call Nyquist criteria. Here the question में थोड़ा सा important part. He don't ask the here you have this is the input signal. You are sampling at the regular intervals. The sampling time here is how much होना चाहिए 2 milliseconds approximately. Because once you take the sample, you should wait until you get the output. You cannot take the next sample. ठीक है? So sample का बीच में कितना time है भाई 2 millisecond का time तो compulsory होना चाहिए approximately. So this will give, he said approximately इसलिए, ठीक है. So one sample और another sample के बीच में 2 millisecond time तो चाहिए. So sampling time is 2 milliseconds. The frequency of the rate at which you are doing the sampling frequency is given by 1 by 2 milliseconds per 100 Hz. So from signals and systems, you might know called Nyquist criteria. If you want to sample any given signal, so the minimum frequency must be that is the sampling frequency and the analog frequency signal uh, are related with the help of Nyquist criteria. So what is that? EFS must be greater than or equal to 2 FM, where the message signal frequency से double होना चाहिए sampling to for the proper conversion of the signal. Very good. चलो next question. So last 4 questions. अरे क्या हुआ? So a 10-bit ADC is used to digitize an analog signal into 0 to 5 volts. The range of maximum peak to peak ripple that can be allowed in the DC voltage will be. चलो भाई, कितना रिपल तक आप इनपुट में ऐड कर सकते, कोई दिक्कत नहीं होता है मेरा आउटपुट में. क्वेश्चन नंबर 22. कम ऑन, ये तो आंसरेबल क्वेश्चन है, टाइम तो हो गया. फर्स्ट फाइंड द रेजोल्यूशन. 5 by 2 power 10 minus 1, 5 millivolts. It is 1 LS. Okay. So plus or minus half LSB. So peak to peak कितना होता है सर? This is a 0.5 LSB. इतना तक एरर तो चलेगा, डिस्टर्बेंस तो चलेगा, ठीक है. So peak to peak is 1 LSB you can add. So peak to peak how much you can? Nearly 5 millivolts तक कोई दिक्कत नहीं, ठीक है. Right. So last 3 questions. Next question. Two more questions, last 3 questions. So that will finish my part of your question series. फिर भी next week में, next Monday, Tuesday, I will take K notes series where I will provide you the short notes for what we call this network analysis and digital circuits. बीच में मैं सोच रहा हूँ आपको कुछ YouTube वाले बच्चों के लिए कुछ क्रैश कोर्स प्लान किया तो कैसा होता है, मैं सोच के आई विल टेल यू, ठीक है. So here the integrated output waveform for the dual slope ADC. Okay. So it may be positive, negative, छोड़ दो. It depends on the type of ADC. Okay. It will be integration, first integration, second integration. Okay. So this is the time for Ti. It is generally given by 2 power n time period of the clock. Because the counter count from 0 to 2 power n minus 1 tak, it will be in the first input side. Then it will change to the reference side. Okay. The time T of an 8-bit counter is of a 4 megahertz. So Ti is equal to how much? 2 power n into time period of the clock. So 2 power 8 into time period of the clock. What is the time period of the clock? 1 by 4 into 10 power 6, 0.25 microseconds. Okay, so 256, 64 microseconds, 0.064 milliseconds. Option B. Very good, Harsha, right answer. आप डिजिटल इलेक्ट्रॉनिक्स भी पढ़ाते हैं? अरे यार, कौन सा क्वेश्चन you're asking यार? Just go through my videos in Kreatryx here, you'll understand. Actually, इस साल पे मैं YouTube में haven't taken any class of the digital. Maybe that is the reason you're asking. Yes, I teach digital. This is my favorite subject in fact. ठीक है. So the next question, थोड़ा सा इसको enlarge किया तो better होता है ना? चलो, read this question. I always love the questions which are very large. इतना ज्यादा लंबी क्वेश्चंस में क्या फायदा होता है? ज्यादा फायदा ये होता है, ज्यादा इंफॉर्मेशन एग्जामिनर ही देती है भाई आपको. He will give you, examiner देता है ज्यादा ज्यादा information. For a, he gives you more information in the question itself. So your job is just to read the question and give the answer. अच्छा, मॉक का मार्क्स तो ज्यादा कंसंट्रेट नहीं करना. 45 to 55 is a good mark. But one thing you check is rank. Second thing you check is where you are committing the mistakes. कहाँ पे जा रहे हैं तुम्हारा मार्क्स, ये चेक करना चाहिए. बिकॉज वो वाला मॉक एग्जाम्स में थोड़ा सा टफ देती है पेपर. उस समय पे क्या होता है ना, इट हैपेंस मेनी पीपल विल गेट लेस मार्क्स ओनली. सो चेक योर रैंक फर्स्ट थिंग. सेकंड थिंग, वेयर यू आर मिसिंग द मार्क्स. सपोज इन ए सब्जेक्ट which you know very well, you missed the marks, then there is some mistake with you, you should cross check. Or there are some questions which are very relatively new, or you are doing some mistakes. ये identify, you should do that analysis, self analysis करना चाहिए. ठीक है. So circuit shown in the figure represent a counter-based unipolar ADC when SOC is asserted. So when you give the start of the conversion signal, okay, then the counter is reset. Okay, fine. It will, the counter counts up. The DAC output grows. When the DAC output exceeds the input value, the comparator switches from logic 0 to logic 1 and disabling the clock and enabling the output buffer by asserting the end of the conversion signal. Okay, it is nothing great in this. Yes or no? Clock there are here. It is as simple as an AND gate will be present here, which we have discussed earlier. Okay, this is the present one. Okay, so this is what we discussed earlier in the counter type ADC. Now that he has specified with the control logic name. Okay, right. So whenever input is more than this comparator, VA is greater than VD, it will give the clock. When VA becomes less than VD, okay, what happens? It becomes the clock input will become 0, and so this will become 0 because VA less than VD. Then that will give you EOC signal, and your buffer will be enabled. That is given by this part. Okay, this signal and the clock will go together. End of the conversion. Okay, this our regular circuit is little different. This one in a different way he has plotted. So it is nothing but a counter type DAC. Assuming all component ideal V reference and DAD output, DAD DAC output and input positive. What is the maximum error of conversion of analog sample? So मैक्सिमम एरर कितना है इस पे हम तो डिस्कस किया. एक स्टेप साइज विच इज इक्वल टू v reference by 2 power n minus 1. ठीक है. So the maximum conversion, maximum error is proportional to v reference, inversely proportional, independent of v reference, directly proportional to clock frequency. Clock frequency पे कोई फायदा नहीं. It is inversely proportional to n and it is proportional to V reference. So it is directly proportional to V reference. बस इतना आसान क्वेश्चन है देखो इतना लंबी क्वेश्चन एक लाइन का आंसर बस if you know the concept you can answer it. So the last question of today's class. So the conversion time of 8-bit successive approximation time type converter with 1 megahertz clock is nearly how much? This is the last question for today's class. So digital का 25 questions कम time पे हो गया ना? I think 1 hour 50 minutes we took. At yesterday network around 2.5 hours it took. Come on, come on. 8-bit successive approximation type converter. SAR type ADC. So time required for the conversion is equal to frequency 1 megahertz time period 1 clock. ऑप्शन डी राइट आंसर इसको 5 सेकंड बाकी है बट मैंने आंसर तो अनाउंस किया बिकॉज इट इज द इजीएस्ट क्वेश्चन हो गया टाइम what is the conversion time SAR type is having uniform conversion time of n clock pulses if you take 8 microseconds sometimes if you take SOC and UOC into consideration some people will give you n plus 2 that is also okay if n is not available in the option so generally counter type 2 power n clock pulses flash type 0 clock pulses and dual slope 2 power n plus 1 and this one n clock pulses. Okay, uniform conversion time is one of the speciality of the SAR type ADC. It takes same equal amount of time with respect of the magnitude of the input. That's all for today. Okay, so these are the batches running on with Unacademy for the GATE and PSU 2023, 24, 25 batches that is for second, third, final year students के लिए. सो आप आईआरएमएस का बैच भी शुरू किया आप लोग आईआरएमएस एंड सिविल सर्विसेज टुगेदर प्रिपेयर करना चाहिए तो यू हैव ए कॉम्बो ऑफर ऑफ जनरल स्टडीज एंड यूपीएससी टुगेदर गाइस अभी तो आप सब्सक्रिप्शन ले लिया तो आपको 23% डिस्काउंट मिलेगा व्हेन यू योर फ्रेंड एनीबॉडी वांट टू टेक द सब्सक्रिप्शन यू कैन यूज दिस सो दिस इज माय टेलीग्राम चैनल आल्सो you just type this you will join the telegram channel if we can communicate further with notes, classes, or your doubts, you can communicate there. Okay. So, yes, important part of your GATE examination preparation you have already entered. So, this month you have 4 examinations. These 4 examinations are really important for you guys because you can understand this is very important to write the mock tests as many as possible to get the real-time experience. Every time saying the same thing. So this video link, my description page is available. The examination link. So please enroll to that. Use the code Shankartan. It is completely free for you, right? So अभी तो अनअकैडमी में 23% ऑफ चल रहा है भाई आपको सब्सक्रिप्शन लेना चाहिए तो यू योर फ्रेंड योर जूनियर एनीबॉडी यू कैन रिफर माय कोड शंकर थैंक यू वेरी मच फॉर योर टाइम आप इसमें जीत लिया तो इवन यू आर सेकंड थर्ड ईयर आल्सो गिव इट ट्राई यार इसमें कितना मार्क्स आए तो कोई दिक्कत नहीं बट गिव इट ट्राई यू गेट एन एक्सपीरियंस सो बेस्ड ऑन योर रैंकिंग यू विल बी गेटिंग दिस ओके थैंक यू वेरी मच Okay, so I am done with my part. Actually, 1 minute, yeah. I hope you know the schedule. Yesterday I have explained already keynotes wala schedule and question series ka schedule. Okay, fine, done. Thank you. Okay, Bhuvneshwari, unlock का practice के लिए we plan in YouTube. Otherwise, so in special classes we plan. Okay, I'll check. I'll plan in special class and I'll update you. Okay, fine. Thank you.